There's a layer of rock in the geological record that shows up on 4 different continents: India, the Arabian Sea, Lake Malawi in East Africa, Malaysia, the southern South China Sea. The same material scattered across an area so massive it's hard to visualize. When geologists first started finding it in different locations in the early 20th century, they treated each deposit like a local oddity. Just weird ash in the sediment. Probably a regional thing. Nothing too exciting. And then someone started dating it. All of it was the same age. Every deposit, same mineral signature, same chemical fingerprint, same timestamp buried in the stone. Roughly 74,000 years ago. Almost exactly. When they ran the numbers on the volume of material ejected, the ash, the sulfur dioxide, the gas clouds that would have been shot into the stratosphere, they stopped and looked at each other the way scientists do when the data is telling them something they're not prepared to handle. This wasn't a volcanic eruption. This was the most violent geological event in the last 2.5 million years. And it went off directly above a population of early modern humans who had absolutely no idea what a supervolcano was. Now here's where it gets strange. Not strange in the wow, interesting history way. Strange in the wait, the numbers don't add up way. Because when geneticists, completely separate from the geologists, started mapping human mitochondrial DNA in the late 1990s, they noticed something that had no clean explanation. The genetic diversity of every human being alive today is small. Absurdly, inexplicably small for a species that had theoretically been spreading across Africa for hundreds of thousands of years. You know how biologists measure genetic diversity in populations? They look at how many small mutations have accumulated in the DNA over time. The more diverse the population, the more lineages survive, the more variation you see. It's basically a molecular clock for how many ancestors contributed to the present. Modern humans, all 8 billion of us, show the genetic diversity of a species that came extremely close to disappearing. Some estimates put the effective breeding population at the worst point somewhere between 10,000 and a few thousand individuals. Total, on the entire planet, not 10,000 in one region, 10,000 everywhere. The entire human species, reduced to something smaller than the current population of a mid-sized college campus. Researchers looked at that number. Then they looked at the geological timeline, and then someone put those 2 data sets side by side and said, huh. The ash layer and the genetic bottleneck lined up within the same rough window of time. The same event that blanketed half the globe in microscopic volcanic glass appeared to have left a signature in our DNA that we're still carrying today. And then someone asked the question that made the whole room uncomfortable. What exactly did these people do to survive it? Now imagine that you are the person at the center of this story. Not an archaeologist holding a sediment core. Not a geneticist staring at a sequence alignment. You. Standing on the southern tip of the African continent, roughly 74,000 years ago, before any of this has happened. You don't know about Sumatra. You've never heard of Indonesia. The mountain that just erupted, Mount Toba, sitting on a fault line in what will someday be called Lake Toba, the largest volcanic crater lake in the world, is over 10,000 kilometers away from you. At first, there's nothing. A few weeks of slightly strange skies, maybe. A haze. Then the temperature starts dropping. Not dramatically. Not all at once. Just colder. Week after week. Estimates from climate modeling suggest global temperatures may have dropped between 1.5 and potentially 5 degrees Celsius in the aftermath of the eruption. In our era, 1.5 degrees is what we're fighting wars over in climate negotiations. In your era, with no heating, no stored food, no agricultural surplus, 1.5 degrees doesn't sound like much until the grass dies. And the grass dies, slowly, then completely. The herds follow the grass. The large game that your entire survival strategy depends on, the wildebeest, the buffalo, the species you've built your tools and your knowledge and your entire way of life around hunting. They start moving. Or they start starving. And then they start disappearing. Entire ecosystems collapsed in the aftermath of Toba. The forests of South Asia, based on pollen records from deep sediment cores, show a dramatic die-off in this period. The archaeological record in South Asia goes almost completely silent. The stone tool traditions that had been building for hundreds of thousands of years just stop. No artifacts, no butchering marks, no evidence of anyone doing anything. Because in many regions, there probably wasn't anyone left to do it. I want you to sit with that for a second. Not because it's dramatic, because it's real. The species that would one day build Rome and sequence its own genome and argue about whether a hot dog is a sandwich. That species came within what might have been a single catastrophic season of simply not existing. So they survived. Obviously because we're here. But here's the part that kept researchers up at night for decades. How? When archaeologists excavated a site called Pinnacle Point, or Cave 13B, on the rocky coast of the Western Cape in South Africa, a site now dating to roughly 164,000 years ago, but with layers of occupation pushing into the Toba period. They found something that did not fit any existing model of how early humans survived environmental collapse. They found shells. Not a few shells scattered around from occasional snacking. They found thick middens. That's the archaeological term for ancient garbage dumps. Packed with the remains of marine mollusks. Limpets, mussels, periwinkles, barnacles. Species that live specifically in the intertidal zone, that strip of coastline that's exposed when the tide is out and submerged when it's in. The researchers looked at this and thought, okay, people ate shellfish. Makes sense. Move on. But then they looked more carefully at which species were represented, and in what proportions, and what the shell sizes suggested about when in the year they were collected. And that's when it got weird. The ancient humans living at Pinnacle Point weren't just picking up whatever was lying around at the water's edge, they were targeting specific species based on the lunar cycle. Here's the thing about shellfish in the intertidal zone that most people have never had cause to think about. You can't just walk up and collect them whenever you feel like it. The best species, the ones with the most caloric value, the large brown mussels and the specific limpets that dominate the Pinnacle Point record, live in the lower intertidal, the section of rock that's only exposed during low tides. Not just any low tide, the lowest low tides. The ones that only happen twice a month during the new moon and the full moon, when the moon's gravitational pull is strongest and aligned with the sun. Biologists call these spring tides. They pull the water back further than usual, exposing a band of rock face that's normally underwater. The people at Pinnacle Point weren't just eating shellfish, they were timing their harvests to the moon. That's not a trivial insight. Knowing that the moon controls the tides is one thing. Tracking the lunar cycle, anticipating when the lowest tides would occur, organizing foraging expeditions around an astronomical event that repeats every 14 days, that requires a level of planning and temporal awareness that most people don't associate with a group of early humans in a survival crisis. Sincere question, when's the last time you tracked something for a month straight? Because I lose my phone charger approximately every 3 days. I have no idea when the moon phase changes. I pay someone to manage my calendar and still miss appointments. And these individuals, operating in the aftermath of what may have been the worst environmental catastrophe in human evolutionary history, when the food supply across the African interior had collapsed, when the world was colder and dimmer and the game was gone, these individuals were managing a foraging calendar based on the orbit of the moon. The researchers analyzing the shell assemblages found that the species composition changed predictably over time in ways that tracked with seasonal and lunar availability. This wasn't random foraging, this was systematic, scheduled, resource-managed exploitation of a new ecological niche. They had figured out how to read the ocean. And here's what that actually means for the survival story. When the interior became uninhabitable, when the forests died, and the game disappeared, and the climatic fallout of Toba made the strategies that had worked for hundreds of thousands of years suddenly useless, a small group of early modern humans on the southern coast of Africa had access to something that the volcanic winter couldn't touch: the sea. The ocean doesn't care about volcanic aerosols blocking sunlight. The kelp forests off the Cape Coast are one of the most productive marine ecosystems on the planet, driven by cold, upwelling currents that were largely independent of atmospheric temperature changes. The shellfish were still there. The tidal rhythm was still running. The moon was still pulling the water back twice a month. The people who could reach that food and who had developed the cognitive sophistication to exploit it systematically had access to a resource base that was essentially immune to the catastrophe killing everything else. This is the survival tactic that shocked archaeologists for decades. Not a weapon, not a fire technique, not a shelter design. A calendar. A lunar foraging calendar, applied to a coastal resource that nobody in the interior could access, at the lowest point in human demographic history. And it worked. The genetic bottleneck was real. The population crashed to levels that make modern extinction crises look comfortable, but it didn't go to zero. Now here's the part that I find genuinely mind-bending. The people at Pinnacle Point weren't just surviving on shellfish. The archaeologists found ochre, red pigment, processed and used in ways that go beyond any functional explanation. They found evidence of heat-treating stone, a technique that fundamentally changes the fracture properties of silkrete and makes it dramatically easier to nap into precise tools. The ochre processing goes back to 164,000 years ago at this site. The shellfish exploitation intensifies dramatically in the periods associated with environmental stress. But there's something else in the record, something subtler. The tool assemblages at Pinnacle Point show a sudden shift during the climatically stressful periods. Bladelets, tiny, precisely manufactured cutting tools, appear in much higher frequencies during the colder phases. Why does that matter? Because bladelets are efficient. You get more cutting edge per gram of raw stone. When your resource base is under pressure, when you're exploiting a tidal zone instead of a savanna, you need tools that work on a different scale. You need precision over brute force. They changed their technology to match their new environment. Not once, not accidentally, not gradually over 10,000 years. Within a detectable window in the archaeological record, within the same crisis period, the toolkit adapted. I don't know what to call that other than intelligence. The kind of intelligence that our comfortable, food delivery having, GPS dependent, 23andMe knowing brains like to think of as distinctly modern, as specifically our achievement, as something that emerged after cave paintings and agriculture and written language. But Pinnacle Point is saying something different. It's saying that the cognitive engine was already running, fully, at 74,000 years ago and probably long before. And when the volcano went off and the world went dark and everything that worked stopped working, that engine didn't stall. It pivoted. Here's what makes this story different from every other prehistoric survival story. Most survival stories are about brute force. You imagine ancient humans as these physically imposing, tool-swinging, mammal-hunting figures who survived because they were tough and because they had been hardened by millions of years of selection pressure. The Toba survival story isn't about toughness. It's about reading the sky, watching the moon, learning a new coastline, figuring out that a limpet at the bottom of a tidal rock face has more caloric value than the one near the top, and that you can only access it twice a month, and that missing that window means your group doesn't eat this week. It's the least glamorous survival strategy in the entire prehistoric record. No mammoth hunt, no dramatic overland migration. Just people standing on wet rocks in the cold, counting days since the last full moon, waiting for the tide to go out far enough. And I find it almost unbearably moving that this is what saved us. Not heroics. Not some dramatic evolutionary adaptation. Noticing. Paying attention to a pattern in the ocean that repeated reliably in a world where almost everything else had stopped being reliable. The world outside was a disaster. The skies were hazy. The grasslands were dead. Everything that evolution had shaped the human body and mind to do for hundreds of thousands of years had become temporarily useless. And a small population of people on the southern edge of Africa went to the beach, watched the moon, and ate mussels until the world recovered. Here's what you're carrying from that moment, right now, in your cells. Every human being alive today descends from a population that squeezed through a genetic bottleneck so severe that the standard measures of diversity are still compressed by it. You are genetically similar to every other person on this planet. Across every continent, every culture, every ancestry, to a degree that would be remarkable in any other large mammal. Chimpanzees in a single national park in West Africa carry more genetic diversity among themselves than the entire global human population does. That's the shadow Toba left on our biology. We are a species that almost wasn't. And the only reason the word almost applies is because a small group of people on a rocky coastline learned to read the tide. There's something in the prefrontal cortex, the part of the brain associated with planning, temporal reasoning, deferred gratification, that is distinctly, unusually developed in Homo sapiens compared to our closest relatives. Neuroscientists have been trying to explain this for decades. What was the selective pressure? What drove the capacity to plan far into the future? Maybe it was this. Maybe the capacity to look at the moon and count days and anticipate a low tide 2 weeks from now. Maybe that cognitive skill, exercised during the most desperate demographic moment in our evolutionary history, is part of what got passed forward. The people who could plan far enough ahead to know when the tide would be lowest were the people who ate. The people who ate were the people who reproduced. And the capacity for that kind of temporal reasoning is sitting inside you right now, being mostly used to decide whether you need to charge your phone before you go to bed. The cryptotephra is still down there. Those microscopic shards of volcanic glass from the Toba eruption, so fine they're invisible to the naked eye, detectable only under electron microscopy, have been found in the sediment layers of Lake Malawi in East Africa, more than 7,000 kilometers from the source. Geologists have pulled sediment cores from the ocean floor and found the layer like a geological bookmark. This is where the world almost ended. This is the exact year. And just above that layer in the archaeological record, at Pinnacle Point, and at a handful of other coastal sites along the southern African coast, you find the evidence of the people who didn't let it. Not a monument, not a weapon. Shells. The remains of a lunar foraging schedule scratched into the archaeological record by the fact that someone, 74,000 years ago, was paying enough attention to survive. So here's what I want you to actually think about. If you were in that situation, food systems gone, interior uninhabitable, everything you know doesn't work anymore, and you somehow ended up on a coastline you'd never exploited before, would you figure it out? Would you notice the pattern in the tide fast enough? Would you look up at the moon and start keeping count? Because I'm honestly not confident I would. I struggle to remember to put the recycling out on the right day, and that happens every other week with a sticker on my fridge. Drop your answer in the comments. I mean it. Would you have made the connection, or would you have been the person waiting for the savannah to come back? I'm genuinely curious which camp people put themselves in. And if this story hit you the way it hit me, the idea that 8 billion people exist because a small group of survivors went to the beach and watched the moon, give this video a like. It's literally the least effort a modern human can make, which feels appropriate given the context. Subscribe and hit the notification bell if you want to keep going down this particular rabbit hole with me. Because the thing about the archaeological record is that every time we dig a little deeper, the story gets stranger. And that layer of volcanic glass in the mud at the bottom of Lake Malawi is not even close to the weirdest thing geologists have pulled out of the ground. Not by a long shot.